Hey gang, what's up? It's your video for 10.5 worksheet, just doing the evens today. So let's get in. We're back to regular polygons like we did in 10.3, but we are not going to be using special right triangles for this. We will be using only trigonometry. Okay, so we have a pentagon here. We're going to go ahead and draw in these little radii. Okay. So it breaks it up into 5 triangles, and so we do 360 divided by 5, and that's going to give us the total number of the angle measure on the inside, which is 72. And then when we draw, I'm going to draw that little smaller triangle here. Okay, and so when we draw in the apothem, which comes right down there, that little apothem, which is what we're trying to look for, the apothem. And then this is the kind of half side length, and then 6 feet is actually the radii right here, just like that. Okay, and the 72 gets cut in half by the apothem to make it 36 right there. Okay, so this is the harder ones to do because my formula is 1/2 apothem times perimeter. Well, I can't actually find either one of these out yet. I have to use my trig. So I'm going to use my trig. I have my eyes on the prize. Eyes on 36. So we have the adjacent and we have the hypotenuse. So that's going to be cosine. So we're going to do the cosine of 36 equals adjacent over hypotenuse. And to get the 6 out, we just multiply it. So 6 times the cosine of 36. What is that going to equal? Really important to make sure that your your calculator is in decimal form. So I have D up there for decimal, so make sure it's in decimal before you continue on. And we get 4.854. I'm going to go 3 decimal places when I answer these ones, but that's my apothem. Okay, so I found my apothem. If you do print out this worksheet, you're going to need extra paper for this. This is not going to be an easy task. Okay, next let's find this piece here, which we don't know, and so that's the O. So we have the apothem, but now we want to find the perimeter. So we're going to need this piece here. Okay, and just let you know that that piece right here, this in blue, is this little half piece of the pentagon. So once we find X, the blue part, if we double it, it should be the full side length, and then multiply by 5, that'll give us the perimeter. So looking at this, we have O and H. We're going to do the sine of 36 equals opposite over hypotenuse, multiply the 6 out. So 6 times the sine of 36 is going to equal 3.526. Okay, so that's what X equals. Now, again, it's only half of it, so what we're going to do is we're actually going to multiply this by 2. I'm going to leave it in my calculator. So that means the side is 7.053. So that whole side length here is 7.053, but then we want to find the perimeter, so the perimeter is going to be 5 sides times that 7.053. Again, I'm leaving my calculator to keep it as legitimate as possible, and the perimeter is 35.267, and so there's my perimeter. So this is by far the hardest one. If you look at number 1, you can actually find the perimeter very quickly by just multiplying 8 times the number of sides. Number 14, 14 times the number of sides. Very simple. This one, when we give the radius, we have to find the apothem and we have to find the perimeter. So now that we found both, we can actually finally plug it into our formula. 1/2 apothem, which is 4.854. times the perimeter, which is 35.267. And for these, you're going to have to always write your answer in simplest radical, or sorry, not simplest radical form, decimal. And so on the worksheet, we're asking for rounded to the nearest 10. Okay, so we're just plugging all this in, and we should get 85.59. So if it's 85.59, we're going to round that to 85.6. And again, this should be your answer for Go Formative. We're not using units of measure. It would be squared feet, but for this now we're not going to be doing that. Okay? All right, moving on. Number 4, find the area of the regular polygon, round your answer to the nearest tenth. Okay, so hexagon with a side length of 4. Okay, so hexagons are a little bit easier for us because we can use special right triangles, which is convenient. So let's just draw out the shape. We have side length 4. That means perimeter is going to be 4 times 6, so the perimeter is 24. So that's very quick to find. We want to draw in our apothem right there. Now it cuts the side length in half, so that becomes 2, and this is 2. So we have our triangle looks like this. 2. We want to find the apothem here, and so if we divide 360 by 6 sides, these are 60 degrees, which makes this apothem cut in half to be 30 degrees. And we have our little pattern of this is going to be S, and this is going to be S rad 3. So S rad 3. So that means my apothem is going to be 2 rad 3. So with those two pieces, we can plug it in and do area equals 1/2 2 rad 3 times 24. I multiply all the whole numbers first. So I'm going to do 2 times 24 divided by 2, which is going to be 24. And then slap on the rad 3, and that's your answer for Go Formative, 24 rad 3. So a hexagon, we can use special right triangles, which is faster than doing it with the other way, where we had to use whatever it's called, Sokotoa. Nonagon. So number 6, we draw a nonagon. Now, I'm not really good at drawing nonagons. You don't actually have to draw these all out, but this one's going to be a tough one. So I'm glad I'm doing this one. The ones with the radius, if you see the ones with radius, you're in for double work. Okay. So number 7, you're going to have some double work here. So let's get started. Nonagon, 9 sides. So I'm going to take 360 divided by 9. That's going to give me my central angle. So my central angle is 40 degrees, but when I break it down to that little half triangle, and that's what really matters, it's this little half triangle, that's going to become 20 because it's half of it. Okay, that's what matters. So I want to find the apothem, and I want to find this piece. Okay, the radius is always the hypotenuse of that little triangle. Okay, now here we go. We are all set. So we just got to go ahead and solve for our pieces, and we know that we have. Here, one second. Let me see if I can get some. Okay, I was looking for another color, so I think I got another color here. So let's go ahead and get that situated. So this is A, H, and O. Let's solve for the apothem first with our eyes on the prize. So our apothem, we're going to use AH. So that's going to be the cosine of 20 equals apothem over 6. Adjacent over hypotenuse, and then multiply that 6 out. So you get 6 times the cosine of 20. What does that equal? 6 times the cosine of 20. And so your apothem is going to be 5.638. I'm just going 5 decimal spots out. And so that's our apothem right there. Okay? Alright, next we need to find x, so that's going to be OH, so we're going to be using sine. So we're going to do sine of 20 equals opposite over adjacent. And again, we can multiply by that 6. So you get 6 times the sine of 20. And that gives us 2.052. So this is 2.052 right here for x. But remember, if we are looking at this shape, it's just kind of like the Pentagon. We really only found half of the side length. So we really want to take that, and we're going to slide over here, that 2.052, and we're going to multiply that by 2, and that should give me my side length. So that's 4.104, and then my perimeter is going to be 9 sides, because it's a nonagon, 9 times the side length. And so my perimeter is 36.938. And so there's the perimeter that goes all the way around my shape. And last but not least, we plug it all in. Area equals 1/2 Apothem 5.638 times 36.938. Okay? So 5.638 times 36.938 divided by 2. So we should get our final answer of 104.1. So that should be our final answer for this one. Okay? Alright, good. Let's move on to number 8, an octagon with a radius. Again, doing the radius ones. Those are the more challenging problems. Okay. Again, I could draw an octagon, but I really don't need to draw the octagon. I just need to draw this little triangle piece here. Okay? And we haven't seen an octagon yet, so we're going to go ahead and do that, but we need to know what the central angle is by dividing it by 8. So 360 divided by 8 will give me my central angle of 45, and then divide that by 2. So remember, the apothem is going to cut that angle in half to give us 22.5. So you get 22.5. The radius is 9. The radius is always that hypotenuse. Googly eyes, and we have to double this up again. Yeah, next one will be easier. And then x right there. So we have adjacent, hypotenuse, and this is opposite. Okay, so you're going to kind of notice we're going to do the same thing again, just slightly changing up the values. So this is really good practice on these tough ones. But the first one to find the apothem is ka, AH, so it's cosine. So that's cosine 22.5 equals adjacent over hypotenuse. Multiply that 9 out. So we get 9 times the cosine of 22.5. So we're going to get the apothem is equal to 8.314. I'm just rounding. I'm not even rounding. I'm just writing the first 3 decimal spots. Okay, good. Next, we want to find and this is the harder part, is finding the perimeter, because this isn't even the full side. So once we find x, we double it, and then we multiply it by the number of sides. In this case, it's an octagon, so it's going to be 8. So let's see if I can make this as neat as possible. Okay, so let's take it step by step. So OH, so we're going to do sine of 22.5 equals x over h, which is 9. Multiply the 9 out. So we get 9 times the sine of 22.5 is going to equal x. And that's 3.444 equals x. But then I want the side length. So to get to the side length, to get from here to here, I need to multiply by 2. Okay, so we're going to multiply this by 2 in my calculator. So now the side length is 6.888, but then I want the perimeter, so I have to multiply by 8 because it's 8 sides. So in my calculator, I multiply by 8, and I get 55.106, and that's my perimeter. So it's kind of like a multi-little step guy there, where we find the x, this little triangle. Again, this little triangle is like this little piece right here. Once we found that 3.44, we doubled it to get the whole thing, which was 6.88, and then there was 8 sides, so we multiplied it by 8 to get the full perimeter. Alright, now we slap it all together. 1/2, 8.314, and 55.106. And we just multiply it. Da-da-dee, da-da-do. These problems are long, but it's okay, because what else we have to do when we're stuck doing math all day? Okay, so it kind of rounds out. So on go formative, you're going to want to put 0.1. So 22 or 229.1. Okay? Bueno. Alright, that was number 8. Now we are on to number 10, a 15-sided polygon with a perimeter of 120. Okay, well, the good news is they gave me the perimeter, but I kind of need the side length. So we need to work backwards here to find the side length, okay, which we can do. If it's 15 sides, the side length, we just have to divide by 15. So we take 120, divide by 15, and my side length is 8. But then remember the apothem cuts that in half, so we have to divide that by 2, and we get x, what we've been calling this x, right, is 4. So we have 4 right here. Alright, I want to find the apothem. We don't care this time about the radius. It's a 15-agon, so we still need to find this angle in here. So 360 divided by 15, that's my central angle, which is 24, and then half of that is 12. So we always get that angle by taking half of the central angle. There's my googly eyes. We have adjacent and opposite this time. So this is our first time using tangent. This one's easier. The tan of 12 equals opposite over adjacent. And remember, when the variable's on the bottom, we can flip-flop these two. So we have the apothem equals 4 over the tan of 12. So 4 divided by the tan of 12. And so we're going to get the apothem to equal 18.818. So there's the apothem. There's the perimeter that was given to me in the beginning. I just got to multiply it all together. Here equals 1/2 apothem, 18.818 times 120. And here we go. Okay, assuming I plugged that in correctly, which I think I did, we should get this as our final answer rounded to the nearest 10. Okay, let's move on. Okay, number 12, we have a regular triangle, which is awesome. I love regular triangles because this makes my life a little bit easier. They did give me the apothem though, which are the radius. With the radius is always the hypotenuse. Now remember, central angle on these are 120. That means that apothem divides it into that. So this is kind of the pattern we're going to get, that special right triangle that's in here. So this is in my 2s position, my s rad 3, and this is s. So s is going to be 3 over here, which is my apothem. And then this is going to be 3 rad 3. Remember, that's only half of the triangle, so the whole side is 6 rad 3. So to find the perimeter, we got to do 6 rad 3 times 3, which is going to be 18 rad 3. So we have our two numbers. Let's go ahead and plug it in the formula. Again, these ones, the special right triangle ones are a lot faster, in my opinion, if you're good with special right triangles. But we'll go ahead and take a look at this one. We got 3 times 18 divided by 2, which is going to give me 27, and then we just slap that rad 3 on, and that should be our answer. Boom, number 12. Okay. All right. Number 14. What a pain, right? What a pain. Not that big of a pain, actually. We can kind of cheat. We've already dealt with a pentagon on the even problems, haven't we? And so we can use the same principle that we had before. So remember, we had a pentagon up here with a radius of 6. Okay, when we had that, we had all of this work shown for the pentagon when the radius was 6. Okay, I believe this one was the pentagon, right? Or was that the nonagon? See, now I'm getting confused. Pretty sure that was the pentagon. Yeah, pentagon. Okay, so we're going to have the exact same triangle with the 36, but instead of 6 here, we're just going to change that out with a 16. So here we go. Let's draw it out. We actually draw it up here. So it's a 30 6 degrees. Put that eyes on the prize. 16, Apothem, and X. Unfortunately, since there's a radius one, we do have to do a double problem, but that's okay. Let me go a little bit faster. So we're going to do Apothem is going to be the cosine of 36 equals Apothem, which is the adjacent over the hypotenuse. Multiply that out, and that's going to give us our Apothem very quickly. 16 times the cosine of 36. So we get the Apothem is equal to 12.944. So there's my Apothem. Like I said, much faster doing it that way. Okay, and then we're going to look for X, which is only half a side length. So then we're going to do sine, because it's opposite over adjacent. So sine of 36 equals opposite over adjacent. Multiply that 16 out. So 16 times sine 36 is equal to, X is equal to 9.404. Then we got to double it to get the side length. So side length is going to be twice that, which is 18.809. But then we want the perimeter, which is going to be 5 times that, because it's a 5-sided polygon, a pentagon. And we get 94.045. And that's my perimeter. So let's go ahead and find the area, 1/2. Come on in. Okay, sorry about that. My son walked in. He's like, "Daddy, I want to see where you work." He just literally walked into the garage to see me work. Anyways, here we go. 12.944 and 94.045. Let's multiply all those together and let's get an answer. Okay, so we plugged it all in, and I got 608.7 if we were to round correctly. So that should be our answer for go formative. Alright, there you go. Solid. Just real quick, 15 says the central angle is 188, the perimeter is 144. What's the area? So you just have to find the Apothem on that one. And so that one is pretty tricky. So if they're telling you the central angle is 188, then all you have to do is take half of it, and then the perimeter is 144. Let's see. You know what? We'll have you skip 15. I don't like that one. That one's too tough. Too tough. Let's go ahead with 16 and 18. Oh, that's right. These were bonus problems. Okay, yeah, bonus problems. I forgot. So I'm going to leave these as bonuses. So see if you can do them on Go Formative. I'm not going to do these, but I'll give you a hint. You're going to find the area of the small one and the area of the big one. And then, so whichever one's bigger, you're going to subtract the smaller one, and I'll give you this guy right here. Okay? So yeah, you just kind of have to find the area of 2 of them. They're pretty repetitive, so 15, don't worry about. 16, 17, 18, bonus time if you like. Just doing 1 through 14 is going to take a lot of time in general. So if you just get 1 through 14 done, I'm happy. You should be happy. All right, I'm out.